Okay.
Hello, my name is Violetta Marari and I work in the Munster Technological University in Cork, Ireland. On behalf of my colleagues, Dr. Catherine Palmer and Dr.
Are we getting that? Yeah.
A.P. McCarthy, as well as the extended Spirit Maths team, I will tell you a little bit today about the Spirit Maths and the Spirit Maths Extra projects. Our journey started in 2019 when we got funding from the National Forum. The National Forum is a national body in Ireland responsible for leading and advising on the enhancement of teaching and learning in Irish higher education. So we got funding in 2019 under this call called Strategic Alignment for Teaching and Learning. We rolled over the Spirit Maths in 2019, and then in 2020 we got more funding from the National Forum and we rolled over Spirit Maths Extra. So I will want to split this presentation in two. I'm going to give you a little bit of an overview what we have done in Spirit Maths, and then I will give you an overview what we are doing this year in Spirit Maths Extra. We started by designing a survey for first-year students to try and understand their perception of mathematics and preferences for digital learning resources. Originally, we were going to administer the survey once, but after COVID hit in March 2020, the team wanted to know what changed in their perceptions, so we administered the survey again in February 2021. We did discover that there are no statistically significant differences between the two surveys, so this allowed us to combine the data from the two surveys. The Spirit Maths projects had several strands, but we originally focused on numerical learning resources. The survey did show that our students wanted videos on past exam papers, digital software that allows them to practice maths questions, and videos showing word solutions. The team then set about to try and do as much of that as possible. Another interesting thing that came out in the survey was that students are very focused on using their own lectures material. So even though it did come up that they do use internet and maths online and textbooks and other stuff, they very much do want to use first and foremost materials provided by their own lecturer. So following the survey, the team did set about developing digital resources. I did speak about the digital resources at this very conference last year, so I will give you just a very, very quick overview on what we did. Okay, so we started with interactive self-assessment questions. So the student would read the question and they will have the opportunity to write their answer in the answer box. The students then would have the option of watching a corresponding video of the solution. And then they'd have the opportunity to practice a question exactly like that one using numbers. The team created two types of videos of the written solutions. The first one is the silent animated videos, the H5P animations, which were very popular and the students liked those a lot. And the second type were non-silent videos created using packages such as Udo Creations. The corresponding numbers questions were created to match the videos. Students would look at the question and they could enter their answer to see if they're correct. Or if they required help, they could click on one of a number of hints. Each question would have between 1 and 5 hints. At each stage, the students could go to the previous part. Of course, they could reveal the answer and then they could try another question like this one. So these were the interlinked resources from the self-assessment question to a video of worked solution to numbers which provided hints, solutions, randomized variables, and customized feedback. Okay, now I will tell you a little bit about the Spirit Maths Extra project and what we set out to do. So firstly, we wanted to do a diagnostic test for our first year students. The second thing, we wanted to do targeted resources and pilot them. And the last thing, we wanted to use analytics to determine the engagement with and the impact of those resources on our students. Okay, so let me tell you now about the first output of the Spirit Maths Extra project, which is the Essential Toolkit Quiz, which is basically our diagnostic test. After a comprehensive survey of diagnostic testing at third level, particularly in Ireland, we learned that a lot of diagnostic testing is concerned with testing students on various topics that they're supposed to know about going to third level, and then establishing a cutoff score such that students scoring below that score would be identified as at risk of struggling with maths at third level. Originally, our idea was a bit different. We hoped to include a large proportion of questions that might be called abstract reasoning, and those abstract reasoning questions were to attempt to capture students' perceived ability and would employ machine learning techniques to come up with a more sophisticated method to identify at-risk students. However, that approach had to be abandoned as it would place a big burden of the diagnostic test administrators. The switch was made then to a diagnostic test based on topics and topic knowledge. So basically, this is what we ended up with. A short test, 15 questions, which takes 30 minutes to complete, and no calculators allowed. This test is played on our Maths Online module. The MTU value of choice is Canvas, so every student in first year that does take a Maths or Stats module would have access to Maths Online, because when they would log into Canvas, this Maths Online module comes up for every one of them. So the Spirit Maths Extra Essential Toolkit Quiz is based on core skills and knowledge. It would help students identify areas that they need help with, and then it would point them towards helpful resources, such as our Academic Learning Center. If a student answers the questions incorrectly, then the toolkit would point them towards various resources, for example, towards a numbers question, or direct them towards watching a video. So our diagnostic test is ready. It is on Canvas, and it will go live in semester 1, 2020. All lecturers can import the diagnostic test into their own maths module. They can see what students are doing in the test. They can use the analytics on Canvas to see the areas that are problematic, and then they can initiate an intervention, whether in their own class or get onto the department or Academic Learning Center. The second output of the Spirit Maths Extra was to pilot the resources to a particular group. We picked the module Maths 6051. This is an essential maths and stats module for business students. It does have a lot of students, and traditionally, this module has quite a high failure rate. In semester 1, we had 6 academic staff from the maths department teaching this module. The Spirit Maths resources were placed onto the Maths 6051 Canvas page. The course coordinator made a video explaining how the Spirit Maths resources can be used. Canvas announcement was made, the links were given, and all the lecturers gave an overview of the resources during class time. So this screen is what the students will see. For example, a past paper, you can see here very nicely embedded. They would have the question, they'd have a video solution, and then they'd have a link to a numbers question. At the moment, the team is trying to measure the engagement of the Maths 6051 students with the Spirit Maths resources, as well as the impact of those resources on their grade. As I said, there were 226 students in total, and over 30% of students used Spirit Maths resources, over 20% of students used the numbers resources, 18.6% of students used Spirit Maths video resources, and 8.4% of students used both. It is interesting that some students chose the numbers and some students chose the video resource. The initial findings are that, as expected, more average lecture views are associated with a higher semester 1 grade. We examined the data using a linear regression model. We use the student's final grade for Math 6051 as our response variable, and then students' leaving certificate points, which is the equivalent of the A levels, video lecture view counts, written notes, view counts, exercise sheets views counts as our explanatory variable. We are finding that, as expected, the living cert points were associated with semester 1 grades, as well as lecture videos and Sprint Maths numbers. This is all I have time for today. If you have any questions, please contact any one of us at the addresses on the slide. Thank you.
Thank you very much. Yeah. So as usual, we encourage people to post questions in the Moodle chat. The link is in the chat. So let's we have a few minutes for questions.
Chris, I think the link that you posted in the chat there might be to the afternoon session, actually, just to warn you that we might need to look in both links.
Oh yes, 606. Sorry, that was embarrassing.
No, we all need a coffee.
Desperately.
Tell us, Violetta, what your future plans are.
Well, at the moment we are looking at the data because the resources were piloted in semester 1 where they're all online, and we use Canvas. So we have all the analytics we will probably have in the best format because they had to use the online environment. So there's a lot of data there. So we are in very preliminary stages of actually gathering and running different models, trying to see what, if anything, correlates to the final grade. Do the views and the Sprint Maths and the living cert grade. Now, obviously they correlate, but trying to find how much, and it's not, we're finding that it's not a determinate influence, and a lot of other things, influence their final grade. But it's just a unique opportunity to see that. We will never have that again. So that's our block of work. We're looking at that, and obviously we are hoping to do the diagnostic test. That's hopefully going to go live. It's been tested with focus groups, and we hope to see, the difference of maybe mature students and students that have maybe English as a foreign language, etc., and see, is there any difference that we can find in that. We did find that it's a poor predictor generally on final grade after talking to colleagues, etc. So it's very much about just trying to help them, direct them to, to the resources that are there, and see, is there any particular weaknesses.
Okay, very interesting. One quick check for questions in. One question, how many people are working on the project?
Well, I mean, the team, it's about 18 people, but we have about 3 people working on the data. We had 2 or 3 people working more on the diagnostic test, and we had 2 or 3 people working on the resources. So I'd say overall about 10.
A sizable team then.
Yeah, and there's a lot of work. It doesn't actually show how much the work the team has done. There's a lot of good resources there. We could only dream of, I could only dream of having those when I was a student. So
right, okay, well, thank you very much. Fascinating, and no doubt we'll have an update next year.
Thank you very much, Chris.
Look forward to that.
Chris squared. Thank you.
So the next talk is Francis Doherty from Chemistry in Glasgow, who's been using Numbas for cross-disciplinary math support.
Hi everybody, my name is Francis Doherty. I'm a lecturer in the School of Chemistry at the University of Glasgow. Today we're going to talk to you about a Numbas project across the university. So I started to look at Numbas for use in chemistry. We looked at using it in online labs. We looked at creating practice questions for physical chemistry calculations. And I found out one of my colleagues in Earth Sciences was also using it. And we're both interested in math support for our students. So we ran a workshop at our Learning and Teaching Conference last year. And there's quite a lot of people in the university interested in general maths support on some basic topics. And we decided that rather than everyone try to create their own separate resources, we would come together to create a numbers resource that could be used across the university. And the idea is it will provide basic math support, and then we can individually add questions about our own subject-specific questions to it. So we got some funding to work on this project, and we decided that it would be really nice to have students involved in creating the resources, and we would like their input on what they would like and what kind of questions would be useful to them. So we have employed 3 students on the project this year, and I'm now going to pass over to them to tell you what they've been doing.
So hello everyone, I'm Tess, and myself, Anna and Michael are the student interns working on the Numbers project. So I'll start by briefly describing the assignment and what we've been doing so far. This is just a little quick slide of all the Numbers project team. So the aim of the project so far has to be to create a maths-based question pool that can be used as a source across schools in the university. And the applications of the question pool are hoped to be quite versatile. So for example, staff can use the pool to create exams or assignments for students, while students can use it in a more independent way, maybe a more self-directed learning for self-testing and practicing questions themselves. So as far as our role went, we initially familiarised ourselves with the Numbers platform and even participated in a training session with the creator of the platform, Christian Lawson Perfect. And then after that, we began kind of combing through existing questions and grouping them into folders, kind of grouped by question type. And we found that the questions seemed to vary in difficulty, but kind of capped at advanced higher level for what we require. So this kind of first task of seeing what was already on the platform gave us a bit of a flavour of the format and style of the questions on the platform, and even allowed us to have a go at the questions ourselves. So the next step kind of involved each of us being assigned a work package consisting of 5 categories that are then further subdivided into groups based on question type. From here, we're to kind of collect around 5 questions per topic, preferably randomized, so that for one given question, you kind of have kind of an infinite number of questions for each question type if you have that randomization. And then we want an adequate level of advice for each question too, just so that when you answer a question, you get a good kind of level of feedback. So making sure that all of these questions had this kind of adequate level of advice in a similar format made kind of communication between staff and students a key thing. This needed to be quite effective. And it was initial to have this kind of initial grouping of questions just to make sure that there was a bit of overlap between our 3 areas of focus. So this structure has given us a good level of structure to progress, and I'll pass on to Michael to let you know a little bit more.
Thanks, Tess. So yeah, as Tess currently said, there are 3 of us working on each one of these packages. For example, package C, which I'm working on and responsible for, has differentiation as a subject area. And for example, I could have differentiation of sin x and cos x as a specific topic within that area. The reason for this is that when lecturers or tutors want to create tests or find questions for students who need to revise to differentiation, for example, they can go into the differentiation subject area and find different questions with varying levels of difficulty. We are currently having meetings at the start of every package to discuss what we want to achieve in each of these different work packages and how many questions are needed for each topic area. We are currently having meetings, we're also using an Excel spreadsheet to keep track of progress and testing of questions so that staff can see at a glance how we are getting on, an example of which can be seen on the slide. The hope is that each of these questions packages will take us 10 hours in total, but that can vary depending on how many questions there already are on the Numbers platform and the difficulty of questions. The hope in the future is we might be able to create degree-specific questions for lectures. For example, for finance, we can have questions that deal with present or future value and problem-solving compound interest questions. I'll now pass you to Anna.
Thanks, Michael. So as student interns, we found Numbers fairly easy to use overall, but it takes time to get to grips with creating questions and coding. It's quite straightforward to copy already existing questions to our bank and adapt them to suit our needs, but starting from scratch is more challenging, as you can see from the examples on the slide. We've developed technical skills whilst interacting with the software and learning to code, and it was also valuable to collaborate with staff members and each other in a more formal working environment, which was new for us. As students, it's also great to not have to wait for a response from lecturers or tutors, but to get instant answers and advice for specific questions. This saves time for both students and lecturers and allows for flexibility. Students can reveal answers before attempting a question to read the advice and learn how to approach it. The randomization feature is particularly useful for repeated practice and areas of difficulty, as students can keep doing questions until they fully understand the topic. This is available through the try another question like this one button. One thing we all agreed upon was how we wish we had numbers when we were transitioning to university, and now during our courses of second and third years. It's very useful to have quick access to a huge range of maths questions, whether as a refresher or to learn a new skill for our course. It's easy to find questions for specific topics if you find something particularly challenging by using the search tool, which allows for personalized learning that fits your needs.
So myself and Dr. Doherty are actually hoping to kind of develop Numbus chemistry questions. So this will kind of consist of us writing questions completely from scratch. So hopefully kind of contributing to the platform on a whole rather than just taking questions, but actually writing our own and adding them in. This is going to mostly cover first and second year physical chemistry topics that we have maybe paper copies of, but would be nice to kind of transform into a digital environment. So this will then allow us to share it with the Numbus community. So that's our next step.
So yeah, thank you for listening, and if you have time to ask any questions.
Sorry, I'm struggling to unmute there for a moment. My mouse is doing weird things. Fascinating, thank you. Francis, you're here, so I hope you're willing to take some questions.
Of course, we're also joined by Tess, one of the students on the video. So if there's any
Tess, good.
perspective, Tess is here.
Thank you. Let's have a look at the. So there's a question here. Yes, asking about the background of the student interns. So maybe you could answer that, Francis. What's the background of the student interns? Are they chemistry students or?
So we thought long and hard about the types of students we wanted, and we decided we wanted students who had a maths background, but maybe who weren't maths students, because everything would come really easy to them. And we wanted people that, maybe maths wasn't their first subject, because there's resources for people whose maths isn't their first subject. So we employed Tess because she had done some maths tutoring in the past, so she had some ideas about teaching it, and she'd done 2 years of maths as part of her chemistry. She's now a third-year chemistry student. And the other 2 students, Michael and Anna, are finance students, and they've done quite a lot of maths as part of their degree. So we wanted people with some maths, but not too much maths.
And there's a question here from Claire saying, is your package available to others?
Not at the moment, it's still in development, but the idea is that we could share some of the resources at a later date. First of all, over the university, but we would like to make a lot of it available to the Numbers community. Our plan is that it'll be ready for our students to use for September.
There's a question in the chat to you, Tess, about how difficult or easy you found Numbers to use. How was that?
I thought it took a bit of getting used to at the beginning. Our training session really helped. And actually that kind of whole process of combing through questions that are already existing and kind of looking at the the setup of the question made it a lot easier to then go in and write your own for some of the question, like the topic types that were maybe lacking. So on the whole, actually quite easy, although it did take a little bit getting used to originally.
Yeah, thank you. Well, thank you. Francis, Tess and everyone else involved in this fascinating project, very interesting. I think we should move on to the final talk. Alistair Wallace is going to talk about automatic marking of R assessments.
Hello there, I'm Dr. Alistair Wallace, and today I want to talk about automatic marking of R assessment. And what I'm describing is for some courses that have been taught at the Malaysia campus where I teach, along with colleagues at the Edinburgh campus of Heriot Watt. So the background is that each year, 2 of the courses I've been teaching are assessed as follows. So there are 2 assignments per course plus final exam. Each assignment has 2 things to submit. A report, which is submitted and marked via Turnitin, where you can add comments and so on, and an R script. And the courses are taught to undergraduate and postgraduate students in both campuses, and it's about 250 students in total. And the aim has been to kind of make assignments interesting for students, assess the students fairly, and kind of have them be realistic to mark. Because especially in the past, large numbers, it can be quite difficult to achieve all these aims. And so the kind of practice that we've evolved over time is each assignment for each course either has parameters depending on the student ID or data depending on the student ID, depending on whether it's more kind of mathematics related or kind of statistics related. And what we get the students to do is to calculate some numbers, vectors, or functions with particular names which depend on their student IDs. And they've got an assignment where they have to write a report summarizing their findings. So for stochastic processes, I create a fictitious company or something like that. Survival models, they've got to fit some models to some data. And what I've set up is a scheme where the code is kind of marked using a combination of Python and R. And in order to be kind of fair to students, most of the marks for the assignment are for the report rather than the code. And the idea is that because we've got different data or different parameters for each student, the different students will have different conclusions. So for stochastic processes, their report will have different conclusions about which is the best company or scheme in the setup. So if it's like an insurance scheme, they've got to try and set up a stochastic model for it and then describe which is the best company or something like that. And then, you know, if we've got some data that's being fit, a model that's being fitted to some data, there'll be maybe a good model or a bad model depending on the student ID. So the students will have different results in terms of hypothesis tests and so on. So that this kind of helps to alleviate issues of kind of plagiarism and so on, especially within the report. So there are a bunch of important things that you should take note of. So you have to be very clear about what is required. So whether you're going to give 0 marks if they use the wrong student ID, you give them 0 marks for descriptive errors. So I've tried to be clear about this from the beginning, but you know, over time I realized I need to be even clearer than what I was to start with. This is an R specific thing, but different versions of R use different random number generators. So you need to specify that. Otherwise, students will get different answers depending on their version of R. It's good to check in advance what results are possible with the different student IDs. I like to provide detailed instructions to the students on what they should actually be doing. So how to check for errors, check that what's submitted matches the requirements. So I'll provide a video demonstrating what to do, and also in terms of submission and checking for errors, and also an R script, which allows them to check that what they've done roughly matches what we're looking for. And I try to also provide some feedback to students on their calculations, even though there's this kind of automated aspect of the assignment. So I'm just going to do a simple demonstration where, not related to my 2 courses, but essentially it's just so that I don't need to give any mathematics background within a short talk. So the students, we're imagining we're given an R script which generates some data in a vector called my data, and then they have to calculate 4 quantities. So quantities 1 and 2 will be numbers, it's the first and last values of this vector. Quantity 3 will be the squares of everything in this vector, so it'll be a vector. And quantity 4 will be a function, which takes the sum of everything in the vector multiplied by some number, which must be given as input. So I'm going to move to the R, I think, first. So this is the what the students are given, the R script that they would be given. So it generates this normally just pseudo-random, normal random vectors of length 10, stand normal, and they'll get a different vector depending on their student ID. And they're meant to write their solutions below and then submit the R script. And here, let me go to like the correct solutions would look something like this. I mean, there would be more details. They would include any plots they create would be here. All their detailed calculations should be here. But I've just kept it nice and brief to make this clear. So this would be kind of what I'm looking for, and I've got a C here just so that I'm going to do the comparison, explain the comparison shortly. So this is the correct solutions, and I go into test submission thing. What will happen is that this is the file that are given that they can check their solutions. So it's just going to remove everything, close any plots, run their assignment, and then it'll print out the 4 quantities. So if I just run these lines, the students can check, oh, okay, I get a number for this quantity, I get a vector, or there's some function defined. So they can check that what they've created matches, roughly speaking, the requirements that have been given. This is, before they submit, they can use this. And so how do I do the checking? Well, one of the things about R is it's difficult to really remove everything while you're in a session. So this is why I'm using a combination of R and Python. So what I will do is I will feed in this myargs thing, we'll feed in stuff from Python, and the first argument, it'll be a vector of length 1, this will be the file name. And then for that file name that's been fed in, I'm going to read in a CSV file, which have got all the names, user IDs, and student IDs. And then I'm going to find the user ID that corresponds to the file I've fed in. And I'm making this kind of realistic. So I'm assuming that when I download from Canvas, I actually have user IDs, but not the student IDs. So these are maybe 2 different things. And so I have to work out which one it corresponds to. And then later I need to then match that up with the appropriate student ID so that I can do the testing. And then, so I run their script. I'm going to call it quantity 1S, quantity 2S are the student answers for the 2 numbers. And then this is the correct one. So I'm going to put in the correct numbers as quantity 1C, quantity 2C in the CSV file. And then I'm going to consider the differences. So I'll take the differences of the 2 numbers, and then I'll take the sum of differences for the vectors, and then I'll apply this function to many values, and then just check the sum of the differences to see whether it's correct. And then I could, see what kind of tolerance level I want and so on. But I'm just going to return, just for simplicity, return everything back into the original CSV file. And so when I run this Python script, what it's going to do is very simply, it's going to run this command, which is my R where it's installed. I have that file I just showed you for doing the comparison. This is the directory where I'm going to look for files. And then I'm just going to run through all of the files in that directory. I could specify only files that have R as their extension. But I'm going to run through all the files, and I'm going to feed into, I'm going to run R, feed in this particular, this is the particular script I want to run, and R to do the checking. Then as arguments will be the file name I want to run. And basically I go through this again, through every file, and essentially I'm going to run the R script I just showed for every file, and then see what the output is. So if I were to run this Python script, what I'd end up with, if I go into the final thing I want to show you, is a CSV file that looks like this. So I've got the student IDs here. I have the user IDs. I'm assuming the file name contains their user ID, but the random number, the vector depends on their student ID. Then I run through it. This student has some errors, so it just come out with a bunch of NAs when I ran it. This student has one quantity correct. So as I said, the first two are their answers for the numbers. The next two are their answers, are the correct answers for the numbers. And these are the four differences. But I didn't include the vector or the function as output in this CSV file. But I can easily eyeball what's happened. So I can see, this student has obviously a completely different number here. But I might be able to, just by looking at it, provide feedback of what they've done wrong. And then finally, if I look at this student, they have the correct numbers. So the difference is 0 for all of them. So that's basically everything I wanted to say. I know that was very brief, but I just wanted to give an idea. So thank you for listening.
Thanks very much. Very interesting. And thank you for joining us, Alistair. Let's have a look at questions and see what we have in the chat. Right, so a classic question here about the R assessment. What about the quality of the code? How are you planning to assess the quality of the student's code here?
Yeah, no, that's a good question. So yeah, sorry, I was quite brief in explaining that all the aims of what I was doing because of the time. So really, this is part of why I said about not giving too many marks for the code, since I'm giving more of the marks for the report. For most of the students are actuarial science students, so I thought, to me, the focus was being able to understand what is a model, what can you say about a model, how good a fit it is, and so on. So that's why I wanted most of the marks to be for that, but at least at the same time kind of test their ability to do coding. So what I did is, I didn't give marks for the quality of the code. I kind of indicate there that I would give feedback, like if I could tell, oh, this student has got the p-value 1 minus the correct p-value or something like that, I can just eyeball that from the Excel. The ones where there's NAs, what I would actually do is run that individually for each student. So I would actually go through all the ones where the thing hasn't run properly, and then I would give them feedback about what's gone wrong with their code, or I would see, oh, it's because they're using a package that I don't have installed on my computer, so I need to run it one by one. Because if I run it via Python, then it won't be able to just install the packages directly. So I wasn't specifically assessing the quality of the code because I wasn't seeing it as a kind of programming course. Yeah, I mean, that's the classic question that comes up with every attempt at assessing coding, I think, with this sort of automatic approach. Can you remind me, how many students do you have? Yeah, so it's about 250 students each year, give or take. Most of them are at the Malaysia campus, and so and typically I set the assignments. I've set the assignments the past couple of years for both campuses. Yeah. So it's a large number of students. So we're trying to give them an interesting assignment at the same time as making it feasible, and that was kind of the aim there. And Chris Graham is asking whether there are opportunities to run other tests and to generate feedback and so on. Have you thought about that?
So to automatically run other tests on student scripts.
Yeah, so I'm thinking to look into that kind of thing in the future, and in fact, I'm interested to see what other kind of options there are for kind of other methods of doing this kind of auto marking. Like, I kind of investigated a little bit, but couldn't find something that kind of exactly matched what I was looking for. And one of the benefits I find for the kind of DIY approach is I know exactly what I'm doing, so I can double check things many times, and I know exactly what's going on. Whereas if I use like some kind of black box system of someone else's code, or like, you know, if I use, I'm thinking maybe to use something like Gradescope in the future has some ability to do this. I would have to really, would want to really understand what's going on there. But yeah, these things like testing for errors, I know that's possible, and actually I discussed it with a colleague before, but it's something I would want to learn and properly understand myself before I implemented it.
So that actually tangentially is related to the question that I put in the chat. There is another follow-up question actually about a very specific question about significant figures, so perhaps you could answer that in the chat later. But my question was a kind of was stepping back a little bit to ask you which other systems you've looked at. I mean, why have you gone down this route on your own from scratch, right? That seems to be, is that, so which other systems did you look at from the R community, and why did you reject them?
Yeah, so I mean, as I say, this is something I'm still learning about. It's something I want to understand better what options there are, and I can't recall the things that I saw, but I saw a couple of things and I was like, I don't fully, it's maybe slightly black box system or something. And I felt like doing something a bit more DIY, and then make sure that I really understood every line, and to make sure I knew exactly what was going on. And it's maybe, I mean, it is a bit less efficient if I'm then going through running any scripts that have errors and then trying feeding feedback about what errors there are and so on. But to me, at least I knew what feedback I was giving, and I understood what feedback I was giving. So that was my
right. So it's about transparency and control and having the things you want to hand, right? Is that the
yeah.
Kind of answer?
So, and I guess part of the reason is that when I was developing this, I had a lot of other things on the go at the same time. So I wanted to make sure it was something that like feasible and would be useful.
Yeah, absolutely. That makes perfect sense, Alistair. Yeah. It's interesting, isn't it? There's a big overhead to collaborating with other people. I know that a former colleague from Edinburgh, Mina Chetnik-Rundle, who's very involved in the R community, was having students in Edinburgh use version control via Git to submit their work, and then she was harvesting their work off GitHub. Have you thought about that kind of approach as well?
So I did think about that, because that is actually used by computer science colleagues at Heriot Watt for, they have the GitLab server, and they do that. But at this stage, I just thought, rather than getting all the students to get GitLab accounts and then they have to learn how to make use of GitLab and so on, I just thought, part of the advantage of what I'm doing is it really requires no additional work from the students. Apart, they just need to submit the R script to the normal link. And there's no additional training, and I just record a video saying this is what you need to do. This is how you check that your script.
Yeah, I think so. In context, Mina's course had a strong professional practice element, and then learning Git was one of the intended learning outcomes. So that needed to be assessed in some way anyway, and that seemed to be a natural way to submit assignments. But if it's just an extra overhead for your students, then it's a different kind of equation, isn't it, really? Yeah, it's fascinating. And what are your long-term, I mean, I'm checking the colleagues, if you've got other questions, please come in or put them in the Moodle site. I am checking that as we're talking, because we still have a little bit of time left. But what are your long-term plans, Alistair, with this? Is it just going to be a personal project, or do you have plans to involve other people?
Yeah, so it started off, I mean, I chatted with some CS colleagues about like their advice, and I've chatted with other colleagues, and I know I've got colleagues who are using a similar thing for another course. So I had a kind of chat with them before they did it. And I hope to kind of now that I maybe have a little bit more time, I hope to kind of work a bit more with colleagues and kind of developing alternative approaches, and I want to kind of refine it over time and see where it goes. But I just thought at this stage I would kind of share it just so that people have an idea of one thing you can do, and it's I just thought it would be it's something interesting, and I just want to kind of explore. And I like programming, but I wouldn't describe myself as a kind of programming is not my first thing. You know, my background's maths, but I just thought this would be something to explore.
Good. So we still have opportunities for further questions for any of the speakers, really. Please, folks, if you want to post them in the Moodle forum or just pipe up on Zoom, that you're very welcome to do so. No, well then
I'm just sorry.
Go on, Alison.
I was just going to try and answer a bit more of one of the other questions. I'm just having a little look at the.
Please do.
So in terms of accuracy and so on, I because they were mostly actuarial science students, I didn't penalize that too much. So what I would do is just say what in the context, what is a reasonable number of significant figures. So if for example the function is going to evaluate to a large number, and then I'm trying to evaluate it against a large range of numbers, obviously the sum of the differences, it might be a bit, but I would kind of think what is sensible based on what I'm looking for. Or if it's like a probability, maybe 0.01 is not sufficiently close because it could make errors and still get that kind of thing. So I was kind of thinking about what would be sensible, and so like in terms of errors that carry through the code, I was kind of thinking what would be a kind of sensible margin of error to penalize. Yeah, interesting. Okay, thank you. Right, let's draw this session to a close. Please remember that, sorry, wrong one. Please remember this afternoon we have another talk, which will be from Ben at the Open University. Ben Mestel will be talking about mathematics e-assessment at the Open University later on this afternoon. So please come along to that. Otherwise, thank you all. I'd like to thank the three speakers. Thank you for coming along, and enjoy the rest of the day. Thank you very much.